Hey everyone, I'm Vaibhav Khandelwal and I welcome you all to Simplilearn's YouTube channel. In this session, we will talk about Doubly Linked List. We shall begin our session by introducing Doubly Linked List. Then we will try to implement it in the code editor. After that, we will try various operations on them like insertion and deletion. Finally, we will sum up what we have learned from this session. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon so you never miss an update from Simplilearn. So without any further ado, let's get started with an introduction to doubly linked list. A doubly linked list is a linear data structure made up of nodes. This linked list is a bidirectional linked list, that is, we can traverse it in both directions. These nodes consist of three parts. First up, data, reference to the next node, and reference to the previous node. Now let's try to implement the doubly linked list in the code editor. As you know, a linked list is made up of nodes. So we will start by creating a node. To create a node, we need a class node. Its members should be defined as public. Int data, node pointer, next, and node pointer ref. Now we will write a function to insert a node at the beginning of the doubly linked list. Void push. Argument will be a node pointer to pointer, add, and int new data. Now let's allocate a node, node star, new node equals new node. Now let's put in the data into the new node. Since we are adding at the beginning, its previous is always null. Now we will link the old list of the new node. Now we will change the previous of the head node to the new node. We will check if head is not null. Then head's previous is equals to new node. Now let's move the head to the point to the new node. Now, let's write a function to print the given doubly linked list. Its argument will be a node. We will iterate it until the node is not null. Out node data and and node equals to node next. Now let's write a code for the main block. We will start with the empty list. Now we will use a push function to push values in the function. Another push function add comma 3, push function ampersand head comma 5, push function head comma 7. Now out doubly linked list then we will call the print list function print the doubly linked list. Let's execute this program. As you can see, we have successfully created our first doubly linked list. Let's get back to our slides. We have now introduced doubly linked list. Now let's discuss some of the operations we can perform on a doubly linked list. We can perform three operations on a doubly linked list. First, traversal, insertion, and deletion. We can perform a traversal in two ways, a normal traversal and reverse traversal. And we can perform insertion and deletion in three different situations, at the beginning, at the last, and at a specific position after a node. Let's discuss these in detail. First up, normal traversal. We can traverse a doubly linked list using a next pointer starting from head to all the way up to tail node. Reverse traversal. Similar to the normal traversal, we will use previous pointer. We will start from the tail node to go all the way up to head node. Now let's try to traverse the doubly linked list in the code editor. Let's start by creating a class node. We will define its members as public, int data, node pointer next, and node pointer ref. Now we will write a function to insert a node at the beginning of the doubly linked list. Void push. Its argument will be a node pointer to pointer head and integer new data. Now we will allocate a node star new node new node parenthesis. Now we will put in the data. Since we are adding at the beginning, so its prev is always null. Now we will link the old node to the new node. Now we will change the previous of the head node to the new node. Now we will move the head to the point to the new node. Now we will write a function to traverse the linked list normally. Void traverse node pointer while loop node is not null, therefore cout node data node equals to node next. Now we will write a function to reverse traverse it. its argument will be a node pointer to pointer head. We will create a node tail equals to head while tails next is not null. This loop is enabling us to reach to the tail node so that we can traverse it from backside. Now, while loop until tail is not equals to head, cout tail data tail equals to tail trev. Cout tail data handle. This last cout statement is only because we are not traversing till the head pointer. Now let's go to the main block. Let's start with an empty list. Node star head equals to null. Now let us create a linked list to test the function. So we will use push function head comma 2, another push function ampersand head comma 3, push head comma 7. Since we are inserting at the beginning, so the actual linked list looks like 7, 5, 3, null. Now we will print the original linked list first. Cout original traverse head out, reverse traversal, reverse traversed, linked list. Now let's try and execute this program. As you can see, we have traversed it in the normal way as well as the reversed way. Let's get back to our slides. Next up, insertion at the beginning. We will create a node with the previous pointer pointing to a null and the next pointer pointing to the head node. Then we will change the head node's previous pointer to the new node and we will change the new node to the head node. Next up, insertion at the end. We have to give the new node's address to the last node's next pointer and change the new node's previous pointer to the last node. Next up, insertion at a specific position. We will change the previous node's next pointer to the new node and the new node's previous pointer to the previous node and the next pointer to the next node and vice versa. Now let's try these operations in a code editor. We will start by creating a class node public node pointer rev node pointer. Now we will write a function push, insert a node at the beginning of the list. Its argument is node pointer to pointer head into new data. We will first allocate a new node star, new node equals new node parenthesis. Now we will put in the data node arrow data is equals to new data. Now we will make the next of the new node as head and previous as null. And new node previous is equals to null. Now we will change the previous of the head node to the new node. First we will check if the head node is null. Then star head previous equals to new node. Now I will move the head to the point to the new node. Now let's write another function to insert a node after a specific position. Void insert after argument will be node pointer prev node int new data. We will first check if the given previous node is null. If yes, then we will give it cout the given node can't be null, and we will return to the function. Or else we will allocate a new node equals to new. Now we will put in the data. Now we will make the next of the new node as the next of the previous node. Equals to ref node. Now I will make the next of the prev node as new node. And make the prev node as the previous of the new node. Now I will change the previous of the new node's next node. If new node next not null, then new node next prev is equals to new node. Now let's write another function Insert a node at the end of the list. Void append. Its argument will be a node pointer to pointer head int new data. First, we will allocate a new node equals to new parenthesis. Now we will create another node last equals to head. Now we will put in the data new node data equals to new data. Now since this new node will be the last node, so its next will be null. If head is equals to null, new node rev equals to null and star head is equals to new node. Return. Or else we will traverse till the last node while last next is not null. Last equals to last next. Now we will make the last node as the previous of the new node. Return. Now we will write a print list function to print this list. The argument is a node pointer node while node is not null. out, node data, node is equals to node next. Now let's write the main block. We will start with an empty list. We will start by inserting 6, so the linked list becomes 6 null, and ampersand head comma 6. Now we will insert 7 at the beginning, push ampersand head comma 7. Now we will insert 1 at the beginning also. Now we will insert 4 at the end. Till now the linked list looks like 1, 7, 6, 4, null. Now we will insert 8 after 7. So insert after head next comma 8. Now let's print this linked list. Let's try and execute this. As you can see, we have created our linked list in the correct order. Let's get back to our slide. Next up, deletion. First up, deletion at the beginning. We have to change the first node's next to null and second node's previous to null. Next up, deletion at the end. We have to change the second last node's next pointer to null and delete the previous node to free up the space. Next up, deletion at a specific position. We will change the previous node's next pointer to the next node and next node's previous pointer to the previous node. Now, let's try these operations in a code editor. We will start by creating a class node public int data node pointer next node pointer ref. Now we will write a function to delete a node in a doubly linked list. Void delete node. Its argument as pointer to the head node. Repeat. Its argument as pointer to the head node pointer. And pointer to the node to be deleted. Now we will check the base case condition, that is if head is null or the node to be deleted is null, then return now if the node to be deleted is a head node, then head is equals to del now if next node of the del not null, that is if the node to be deleted is not the last node, then else next previous equals to else previous. Now we will change prev only if node to be deleted is not the first node. So if del prev not equals to null, then del prev next equals to Del's next. Finally, we will free the memory occupied by the Del. Free Del. Now let's write a function to insert a node at the beginning of the doubly linked list. Void pointer to the head node pointer and int new data. We will allocate the node. Now we will put in the data. Since we are adding at the beginning, so prev is always null. Now we will link the old list of the new node. Now we will change the prev of the head node to the new node. Now we will move the head to the point to the new node. Now let's write print list function. Node pointer node while node is not equals to null. Cout node data node equals to node next. Now let's get started with the main block. We will start with the empty list. Now we will create new nodes. Push %head, comma 2, push ampersand head, comma 4, push ampersand head, comma 6, push ampersand head, comma 8. Now let's print this list. Cout original list Now we will call the print list function add Now we will delete the node from the doubly linked list. Here we are deleting the first node. Next, let's delete the last node. Now the modified list should look like 4, 8, let's try and print this. Cout modified print list head. Let's try and execute this. As you can see, we have deleted all the nodes except for 6 and 4. Let's get back to our slides. At last, let's sum up what we have learned in this session. First up, we have recognized doubly linked list as dynamic data structures. Next, the doubly linked list offers faster insertion and deletion operation. Next up, doubly linked lists are bidirectional linked list. That is, we can traverse it in both directions. Finally, a doubly linked list is faster at reverse traversal. And this was all for today's session. Hope you guys found it informative and helpful. If you liked this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.